All right, sorry about that. Got cut off there. So let's go back to this one. So we have a plus b to the fifth. So we know it's going to be 1, and there's going to be a 1 over here. It's a to the fifth, b to the 0. That's easy. This will be a to the fourth, b to the first, a to the third, b to the second, a to the second, b to the second, right? A to the first, b to the third, and a to the 0, b to the fourth. Whoa, I messed up somewhere. 0, 1, 2, 3. Sorry. That's 4, that's 3, wasn't it? 2, yeah. 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. I miscounted there. Okay, so then now what are your coefficients? Well, we know 1's on the outside. Well, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. And there's the expansion. Can you imagine writing out a plus b 5 times and then foiling and multiplying? It's going to take forever. All right. So now, what's the top row of Pascal's triangle? It's called the 0th row. Why is it called the 0th row? Because it's a plus b to the 0, which is 1. The next row is called the first row because it's a plus b to the first. In general, the nth row in Pascal's triangle gives the coefficients of a plus b to the n. So we'll let that sink in a second. And let's look at the next page. Okay, so watch for these characteristics as we do the following problems. The number of terms in one is 1 more than the power of the expansion n. So if you had a plus b to the fifth, you know you're going to have 6 terms. If you have a plus b to the third, you're going to have 4 terms. So the coefficient of the first term and the last term is always 1 before we simplify. The coefficient of the second term and the next to last term is always n before we simplify. Did we notice that? Check it out. 2, there's a 2. Next to last it said 3 and 3. Second and next to last. Second and next to last are the same as the exponents. Interesting. Now, the sum of the exponents is always n before we simplify, and you're going to see that here on the third example. So, now let's build x plus 2 to the fifth. Oh, so now we actually have some numbers. Well, let's write this out. X plus 2 to the fifth would literally mean x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. Well, we have a shortcut now. So we know that that's going to be 1x to the fifth, 2 to the 0, right? Plus 5x to the fourth, 2 to the first. Plus, ooh, what's after 5? Anybody remember? We can write it out or we can go back to this. It's 10, isn't it? 1, 5, 10, 10, 5, 1. So it's 10. 10, x cubed, 2 to the second. 10, x squared, 2 to the third. 5x, 2 to the fourth, plus 1, x to the 0, 2 to the fifth. Now, this now has a little more, we got to go another step. Now, how did I know this was 10? Because I looked on the front. Okay, we just looked at our triangle. Well, what's 2 to the 0? Well, that's 1, isn't it? So this is just x to the fifth. We got to simplify this. What's 2 to the first? 2. What's 2 times 5? 10. So it's 10x to the fourth. What's 2 squared? 4. 4 times 10. 40x cubed. What's 2 cubed? 8. 8 times 10, 80. 2 to the fourth, let's see, that's 16 in it, times 5, that's also 80. And then we have x is 0, which is 1 times 1, 2 to the fifth is 32. And voila, we just used Pascal's triangle to do the binomial expansion of x plus 2 to the 5th power. Kind of a shortcut there, isn't it? Okay, now what about negative signs? Well, we're going cubed, so we know it's 1, 3, 3, 1, because this is 0, 1, 2, 3, 4, 5, 6. So this is the third row, so it's going to be 1, 3, 3, 1. Okay, so here we go. 1, 3, 3, 1. So 1x cubed negative y to the 0. So you got to take that negative with it. 3x squared negative y to the first. Notice these have to add together to be 3. Plus 3x negative y squared. 1 plus 2 is 3. Plus 1x to the 0 negative y to the third. Now all we do is simplify it. Okay, well anything to the 0 power is 1, so that's just x cubed. What's negative y to the first? Negative y, isn't it? So this would be minus 3x squared y. What's negative y squared? Positive y squared. So this would be 3xy squared plus, again, negative y cubed is, that should be x to the 0, shouldn't it? Sorry about that. Yeah, that's 0 power. So that's just simply negative y cubed, and there we go. That's the expansion. I'll let you look at that a little bit. Okay, so how do we do this bird? First 3 terms. Now it only says the first 3 terms. We can work it all out, but we're not going to. Let's just do the first 3 terms. Okay, we know it's going to start with 1. Then the first one is going to be 3x squared to what power? 6. Then negative 5y to the 0. Plus, what's always the second term and the next to last term? The actual n, which is a 6. So 3x squared to the 5th times, and it's always times, negative 5y to the first. Plus, what's after 6? You may remember, well, we can write it out, or we can go to the front. 15. 15 is next. Okay, so we're going to go 15, 3x squared to the 4th, negative 5y squared, plus dot, 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 because we're going to keep on going if we had to go all of those. But we're only going to do the first 3, because that's all it asks for. Okay, now if you look at this, yes, you have to take 3 to the 6th power. You also have to take x squared to the 6th power. So if I do that then, if I take 3 to the 6th, I get 729 here. So this is going to be 729 x to the 12th, right? Because when you raise a power to a power, you multiply. This is 1, so we don't do anything with it. Then we go here. Okay, and I'm not going to put a plus sign because I see a negative 5 to the first power, negative 5y to the first power. So I know this is going to be negative, so minus. Now, I have to take 3 to the 5th first, then times 6, then times negative 5. So 3 to the 5th is 243. I'm going to multiply it by 6, and then times negative 5, and I'm going to get 7,290. That's my coefficients. Then I have x to the what? 10th, right? X to the 10th, y to the first. Why y to the first? Because y to the first is in the negative 5y, right there. Then I'm going to have, I think we'll have a plus here, right? Negative squared is positive. So we're going to have 3 to the 4th 3 to the 4th on your calculator is 81. Should have known that. 5 squared, negative 5 squared is 25. So I'm going to take 81 times 25 times 15, the number in front. That is 30,375. X to what? X squared to the 4th is 8, and then it would be y squared. Now you're looking at this saying, whoa, wait a minute, Mr. Thamer, the exponents don't add up to n anymore. No, they won't, because you have an x squared term there. Now, what's interesting, though, watch what happens, though. 12, what do they add up to here? 11, 10, so they are decreasing. They will continue to add, but they're just decreasing. So it's kind of interesting there. All right, now, the end of this here. Oops, sorry about that. How many terms will be in the binomial expansion 2x plus 3y to the 10th? How many terms will be in there? Right, 11. It's always one more. Now write the first two terms of the expansion. Well, that's easy. 1 is always my first coefficient. I'm going to take 2x to the 10th and 3y to the 0. And I'm going to add that to the next term, which is always going to be the second number, is always going to be the exponent. So 10 times 2x to the 9th, 3y to the 1st. Notice how they do add up to 10, plus dot, dot, dot. Only once the first two. So 2 to the 10th, 2 to the 10th is 1,024. So this is going to equal 1,024 x to the 10th. And then that's 1, plus, now we got 2 to the 9th, 512, times 10, times 3, correct? 3 to the 1st. That is 15,360 x to the 9th, y to the 1st, plus dot, dot, dot. Pretty interesting, huh? Sorry about that. Now, how many terms will be in the binomial expansion x to the half plus 1 all to the 30th power? How many terms? Right, we just add 30 and 1. We get 31. Now we're going to write the last two terms of the expansion. Okay? If we write the last two terms of the expansion, we're going to do the last one, you know, is going to start with a 30. So this is going to be dot, 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 plus 30, and then x to the half to the, what number would it be? 1, right? Because the last one's going to be a 0, times 1 to the 29th. Remember, these two have to add to 30, plus 1, x to the half to the 0, 1 to the 30th. So that would be, what, 1 to the 29th is 1, x to the half to the 1 is 1/2. So that's simply going to be 30x to the half. And then I believe that all is going to be 1. And that is the binomial expansion using Pascal's triangle to help us accomplish that.